January 12, 1945. Ardennes, northern France. The morning air was sharp, slicing through layers of wool and leather as frost clung to every ridge and hedgerow. A lone P-51 Mustang climbed into the pale winter sky, its aluminum frame glinting faintly under the low sun. The canopy was gone, removed for speed, for daring, for something few dared even consider. Fellow pilots trailing behind stared in disbelief. How could a man survive, let alone fight, exposed to wind and ice at such altitudes? He gripped the controls, muscles taut, every vibration transmitted directly to his hands. Ice sparkled along his goggles, yet he climbed relentlessly, feeling the aircraft respond to every subtle movement. Below, German jets appeared, their sleek forms cutting through the clouds with a predator's precision. Conventional wisdom dictated that the Mustang could never outclimb them, especially with the pilot fully exposed. But the Mustang responded as if alive, surging upward with a speed that defied expectation. Jets strained to keep pace, engines screaming against the cold. The pilot's calm focus, his trust in the machine, turned a moment of recklessness into a dangerous advantage. In that thin, freezing air, the impossible was unfolding. One man, one Mustang, outclimbing every German jet in sight. By late 1944, the skies over Western Europe had become a deadly arena. The Luftwaffe, though diminished, still operated advanced aircraft like the Messerschmitt Me-262 jet fighter and the Heinkel He-162, capable of speeds the Mustang could rarely match. Allied pilots had learned to respect these machines, knowing that a miscalculation of altitude, angle, or timing could be fatal. Air combat had evolved from dogfights of biplanes into a complex calculus of speed, climb rates, and engine performance. The P-51 Mustang, introduced in 1942, was already legendary. Designed with long-range capability and powered by the Packard V1650 Merlin engine, it could escort bombers deep into enemy territory and engage both fighters and interceptors. Its aerodynamic design balanced speed and maneuverability with an emphasis on endurance and high-altitude performance. Standard doctrine emphasized flying with the canopy closed to maintain optimal aerodynamics, protect the pilot, and ensure engine efficiency. Yet, pilots increasingly experimented with unorthodox methods, pushing their aircraft beyond conventional limits. Flying without a canopy was considered reckless. The biting wind at 20,000 feet, combined with the cold of winter skies, made every second physically punishing. Frost formed on instruments and goggles, visibility decreased, and exposure sapped energy and focus. Few dared attempt it, and those who did were regarded as audacious or outright foolish. Yet for certain pilots, the risk was outweighed by the potential advantage: reduced drag, lighter weight, and the ability to climb faster than expected. In an environment where milliseconds determined life and death, even small gains could be decisive. German jets, like the Me-262, were technologically advanced but not invincible. They excelled at speed in level flight but had limitations in climb performance and low-speed maneuvering. Allied intelligence had noted these traits and encouraged pilots to exploit weaknesses through tactical ingenuity. Mustangs, while slower on paper, could outclimb or outmaneuver jets under specific conditions, particularly if a pilot understood aerodynamics intimately and was willing to take calculated risks. The canopy removal, an unorthodox adjustment, amplified this potential. Pilot culture emphasized both skill and daring. Crews trained for split-second decisions, mastering angles of attack, energy conservation, and situational awareness. Every mission required anticipating enemy behavior, coordinating with fellow aircraft, and managing one's own limitations. Human instinct, combined with mechanical understanding, could outweigh raw technological superiority. For a pilot willing to expose himself to the elements, flying without a canopy became a calculated gamble, a way to gain an edge that instruments and manuals could not provide. Airfields in northern France were hubs of preparation and repair. Mechanics fine-tuned engines, calibrated instruments, and maintained control surfaces. Pilots reviewed maps, intelligence reports, and weather conditions. Each flight demanded careful calculation, yet history showed that innovation often emerged from improvisation. Minor adjustments to weight distribution, trim, or drag could yield unexpected performance benefits. These small advantages, imperceptible on paper, often determined the outcome of encounters with German jets. By January 1945, the Ardennes had become a proving ground. The dense winter atmosphere, unpredictable thermals, and patchy visibility created both obstacles and opportunities. Pilots familiar with the terrain could exploit rising columns of air to gain altitude, intercepting faster aircraft at critical moments. The combination of mechanical design, human skill, and environmental mastery defined success. In this theater, the conventional wisdom of "keep the canopy closed" clashed with innovation born from necessity and daring. Within this context, one pilot prepared to challenge expectation. He understood his Mustang, knew its quirks, and calculated the risk of exposure to wind and cold. His plan was audacious: remove the canopy, reduce drag, and attempt a climb that even the fastest jets might struggle to match. Observers dismissed it as reckless, impossible, or suicidal. Yet within the physics of flight, human skill, and the limits of aircraft performance, there existed a window where this gamble could yield extraordinary results. Normandy's skies were a laboratory of experimentation and survival. Every flight tested boundaries: engine capacity, aerodynamics, human endurance. The stage was set for a confrontation where one pilot's willingness to defy convention, combined with mastery of his aircraft, would create an advantage no one anticipated. The elements, the machine, and the enemy would all collide in a moment of reckoning, proving that daring and ingenuity could redefine what was possible in the final months of aerial combat. The human body was not designed for exposure at 20,000 feet. At that altitude, the air was thin, temperature plummeted, and oxygen levels could sap judgment as quickly as strength. Pilots in enclosed cockpits were already at the edge of endurance, relying on heated suits and supplemental oxygen. Flying without a canopy amplified every danger. Frost clung to clothing, wind whipped against the face, and the slightest lapse in concentration could have catastrophic consequences. Yet the potential benefits were undeniable. The Mustang shed weight, drag decreased, and climb performance increased. Aerodynamics played a decisive role in this gamble. The P-51's laminar flow wing and streamlined fuselage were designed for speed and endurance. Drag from the canopy, though modest, affected acceleration and climb rates at high altitudes. Removing it allowed the airflow to pass more cleanly over the fuselage, reducing resistance and increasing lift efficiency. In practical terms, this adjustment could yield a few hundred feet per minute of additional climb, enough to challenge the performance of German jets in sudden altitude contests. It was a subtle change, invisible in manuals, yet transformative in the hands of a skilled pilot. Engine performance was critical. The Packard Merlin engine required careful management of throttle, supercharger settings, and mixture ratios. Pushing the engine too hard could result in overheating or detonation. Pilots trained extensively to balance these variables, maximizing output while avoiding mechanical failure. The combination of an optimized engine and reduced aerodynamic drag created a narrow window in which the Mustang could climb faster than a Me-262 or He-162 under certain conditions. It was not guaranteed success, only potential. Allied pilots understood the tactical significance. Altitude conferred advantages in speed, targeting, and energy retention. A fighter above an enemy could dictate engagement, choosing when to dive, turn, or evade. German jets, while faster in level flight, could be vulnerable during climbing maneuvers, particularly if the Mustang pilot anticipated their trajectory and conserved energy. By exploiting this knowledge, a canopyless Mustang could turn perceived vulnerability into a decisive advantage. Weather and atmospheric conditions further complicated calculations. January skies were often turbulent, with strong winds, cloud cover, and variable thermals. Pilots had to interpret these invisible forces, adjusting pitch, roll, and throttle to maintain stability. Mistimed maneuvers could lead to stalls, spins, or engine stress. Yet these same conditions offered opportunities. Rising thermals, updrafts along ridges, and pockets of thinner air could amplify climb rates when harnessed correctly. The pilot who mastered both machine and environment could achieve results that seemed impossible to others. Training emphasized intuition and observation. Each pilot memorized engine sounds, control pressures, and the subtle signs of airflow over the wings. A seasoned Mustang pilot could feel changes in lift and adjust instantly. When combined with the canopy removal, these instincts became critical. The aircraft responded faster, but only to those attuned to its signals. In this sense, technology alone was insufficient. Human skill was the multiplier, turning a mechanical tweak into operational superiority. By late 1944, the Luftwaffe's jets were feared but predictable. Their engines excelled at high-speed interception but consumed fuel rapidly, limiting time in sustained climbs. Allied intelligence noted this vulnerability, advising pilots to force jets into altitude contests where they might stall or exhaust fuel. The canopyless Mustang represented an unorthodox application of this principle. By climbing faster than expected, the pilot could seize positional advantage before jets reached optimal firing conditions, upending the conventional balance of power. Within the Ardennes, every flight carried these stakes. Pilots calculated angles, engine settings, and wind effects before committing to altitude. Each sortie tested the limits of human endurance, mechanical reliability, and aerodynamics. In this context, one pilot's audacious plan, to remove his canopy and climb aggressively, was not a reckless whim but a calculated risk, informed by knowledge, experience, and observation. The stage was set for a confrontation that would defy expectations and redefine what was possible in late-war aerial combat. The Mustang had always been fast, powerful, and reliable. Its Packard Merlin engine, a licensed copy of the Rolls-Royce design, provided high-altitude performance that made long-range escort possible. Pilots praised its maneuverability and responsiveness, yet conventional wisdom dictated flying with the canopy closed. Every pilot knew the aerodynamic benefits of the canopy: smoother airflow, protection from wind, and a controlled cockpit environment. Removing it was considered reckless. But for one pilot, audacity became strategy. By opening the cockpit, or removing the canopy entirely, he reduced drag along the fuselage, allowing the aircraft to climb more efficiently. The impact was subtle but measurable. Tests and experience showed that even small reductions in drag could translate to dozens of feet per minute of extra climb at high altitude. In a contest with German jets like the Me-262, where the advantage was speed rather than climb, this marginal gain could make the difference between survival and destruction. He leaned into the controls, feeling every vibration and shift in air pressure. The wind ripped across his face, biting through layers of clothing, frosting his goggles with tiny shards of ice. He was exposed to extreme temperatures and turbulence, yet his focus was unwavering. Each adjustment, slight throttle increase, rudder correction, or pitch change, was informed by instinct honed through hours in the cockpit. He had memorized the Mustang's responses to every nuance, and now he leveraged that knowledge to its utmost limit. The mechanical simplicity of the Mustang worked in his favor. Its airframe was sturdy, responsive, and predictable. By removing the canopy, he reduced weight slightly and allowed airflow to pass directly over the fuselage. This reduced pressure on the control surfaces, making the aircraft feel more immediate in response. At high altitudes, where air density was low and minor adjustments could be magnified, this gave him a responsiveness that few jets expected. German pilots, relying on assumed limitations of Allied aircraft, underestimated his climb rate. Engine management became critical. The Merlin required precise handling of throttle, supercharger, and mixture. Pushing the aircraft to climb at extreme rates risked overheating or detonation. Yet he had practiced these limits extensively, learning to balance power with sustainability. Every climb, every adjustment, was deliberate. He understood that his performance was a combination of machine capability and human judgment. Without this skill, the aerodynamic benefit of flying canopyless would have been irrelevant. Tactical advantage emerged quickly. German jets, designed for straight-line speed, could not climb as efficiently in immediate vertical bursts without risking engine strain. By anticipating the jet's path and using his superior climb at critical moments, he could dictate engagement terms. This wasn't speed alone. It was the interplay of aerodynamic insight, mechanical reliability, and human daring. Each ascent positioned him above the enemy, where potential energy converted to maneuvering superiority and firing opportunity. The cockpit was harsh. Cold seeped into gloves and flight suits. Breathing required more effort, oxygen levels lower than in a closed canopy. Instruments fogged or froze in places. Yet each challenge reinforced focus. The pilot adapted, finding rhythm in the chaos. Wind noise, vibration, and the roar of the Merlin engine became part of a sensory feedback system. Every adjustment, from rudder to throttle, felt immediate and purposeful. The aircraft became an extension of his body, responsive in ways few pilots could exploit. Observation played a critical role. The pilot scanned the sky, noting jet positions, engine trails, and cloud formations. He anticipated their movement, aligning his climb and approach to exploit weaknesses in both performance and timing. Jets that expected predictable engagement were surprised by the Mustang's rate of ascent. The combination of mechanical change and human insight created a synergy that could not be calculated in manuals or predicted by engineers. It was improvisation rooted in physics, executed flawlessly. The result was extraordinary. In every engagement where altitude mattered, he consistently gained the upper hand. Jets that should have outrun or outclimbed him found themselves struggling to intercept. Positioning became his ally, turning what had been a marginal mechanical adjustment into a decisive advantage. The canopy, once a symbol of protection and convention, had become a limitation. Its removal unlocked performance potential that few dared explore. Even fellow pilots, initially skeptical, observed the results with growing respect. The Mustang's behavior exceeded expectations, defying assumptions about aircraft limitations. What seemed reckless, exposure to wind, frost, and extreme altitude, proved to be an innovative adaptation. Human skill, mechanical knowledge, and a willingness to challenge convention had transformed a standard fighter into a high-climb, agile predator in the skies. By the end of these trials, the principle was clear. Innovation did not always emerge from design or experimentation. Sometimes it appeared in the margin between rules and reality, between expectation and daring. The canopyless Mustang was faster in climb than any German jet in those moments, not because of new technology, but because human ingenuity recognized and exploited latent potential. In that convergence of machine, human skill, and circumstance, history itself seemed to tilt in favor of the bold. The German pilots were seasoned, trained to exploit the weaknesses of Allied fighters. They knew the P-51's strengths but expected limitations, especially in climb. When the Mustangs surged upward faster than anticipated, the jets hesitated, even momentarily. That split second of uncertainty became critical. The canopyless pilot had altered the dynamics of pursuit without firing a single shot. Every jet in formation had to recalculate its approach, its energy, and its timing, confronting a scenario for which no prior training had prepared them. The effect on morale was immediate. German crews had been conditioned to dominance in the skies. The Me-262 could outpace any piston engine fighter, its engine screaming at levels unmatched by conventional aircraft. Yet the Mustang's unusual climb disrupted confidence. Pilots who had assumed a predictable engagement were suddenly forced to react, their instincts challenged by the unexpected. Hesitation replaced aggression, and the advantage of technology alone was diminished. Within the Mustang cockpit, the pilot remained calm. Frost formed on his goggles, wind tore at his gloves, and the roar of the Merlin engine filled every sense. Yet he operated with precision. He was fully aware of the psychological impact his maneuvers were having. The combination of audacity and technical mastery made him unpredictable, forcing enemy pilots to second-guess even straightforward intercepts. In aerial combat, perception could be as deadly as firepower. Human skill amplified the advantage provided by the mechanical adjustment. The pilot instinctively timed climbs and dives to exploit weaknesses in jet engines, forcing them to throttle back or adjust trajectory. Even a few seconds gained in vertical positioning allowed him to dictate engagement, choosing when and how to attack. The canopy-less Mustang, lightened and streamlined, responded faster than the German pilots expected. It was a lesson in improvisation, subtle, unplanned innovation that altered outcomes on the fly. The tactical implications extended beyond the immediate dogfight. Fellow Allied pilots observed the unusual climb and began to understand the possibilities. Escort missions, interception runs, and patrols were reconsidered. Small adjustments, weight distribution, canopy removal, timing of throttle application, were now seen as potential multipliers in performance. What had once been considered reckless risk became an opportunity for tactical superiority. Enemy reports reflected frustration. Luftwaffe pilots recorded unexpected vertical agility and anomalous climb rates in their logs. Engineers and commanders struggled to reconcile these observations with known aircraft specifications. No technical manual explained how a piston-engine fighter could challenge the performance of a jet under certain conditions. For the Germans, the canopy-less Mustang became a variable they could not predict, a mechanical and human anomaly that upended their assumptions. Environmental factors contributed to the advantage. Winter thermals, cloud cover, and thin air at altitude interacted with the Mustang's lighter, streamlined configuration. The pilot read these invisible forces intuitively, adjusting pitch, angle of attack, and throttle. Where jets relied on raw engine power, the Mustang relied on precision and understanding of the physics at play. Wind direction, rising air columns, and subtle pressure differentials became tactical tools rather than obstacles. The combination of mechanical nuance and human judgment created a rhythm to the engagement. The pilot executed maneuvers that were fluid yet deliberate. Rolls, climbs, and dives were timed to exploit every second of the jet's limitations. Observers later described these sequences as surgical in their execution, though nothing had been pre-planned in the strict sense. Improvisation, informed by experience and acute observation, had become a decisive factor. Psychological warfare was embedded in every movement. The exposed cockpit, far from being a vulnerability, communicated daring and control. Enemy pilots, witnessing this audacity, faced doubt. Could a man survive this high-altitude exposure? Could he continue to climb, maneuver, and strike with such precision? The answers disrupted their focus, delaying decisions and creating openings for attack. Risk, once individual and personal, became a battlefield multiplier. The Mustang's performance challenged traditional metrics of superiority. Jets were faster, more powerful, and technologically advanced, yet they were constrained by engine limitations and predictable climb behavior. The pilot's innovation, simple in concept but difficult to execute, shifted the balance. The aircraft became an extension of human intuition, converting aerodynamic subtleties into practical advantage. Positioning, timing, and perception now outweighed raw speed in critical moments. Each engagement reinforced the lesson. The canopy-less Mustang repeatedly outclimbed jets under specific conditions. German formations, initially confident, now approached with caution. Allies began to recognize that human adaptability could exploit minor mechanical deviations. Small adjustments to weight, drag, or technique could yield results that traditional engineering analysis could not predict. In this interplay between human, machine, and environment, the laws of probability bent in favor of audacious pilots. The implications reached beyond the pilot's own sorties. Word of the tactics spread informally through units, inspiring others to reconsider assumptions about aircraft limitations. Risk assessments were re-evaluated, and pilots were encouraged to explore subtle innovations within operational boundaries. The episode became a testament to the power of observation, ingenuity, and the willingness to push beyond convention. Ultimately, the Canopy-less Mustang was more than a machine. It was a demonstration of how minor mechanical changes, combined with skill and audacity, could redefine aerial combat. German pilots confronted an opponent who defied expectation, forcing them to adapt in real time. In this convergence of human daring, environmental awareness, and mechanical nuance, the pilot had turned a simple modification into a decisive advantage, reshaping the dynamics of late-war air engagements. January 14, 1945. Northern Germany, above the Rhineland. The sun barely pierced the low winter clouds as the Mustang crested a ridge of thin air. Below, the gray fields stretched endlessly, interrupted only by patches of forest and frozen rivers. German jets had been reported in the sector, patrolling for any Allied aircraft daring to escort bombers or probe the front lines. Most pilots would have approached cautiously, yet he angled upward, exposing himself fully to the cold, wind, and the biting chill of high-altitude frost. The first Me-262 appeared like a shadow across the horizon. Sleek, menacing, its engine screamed with raw power, faster than any piston fighter could match in level flight. Allied pilots nearby flinched, expecting the Mustang to fall behind. But he continued the climb, canopy removed, feeling the plane respond instantly. The drag reduction was subtle but real. Every foot gained in altitude widened the distance between expectation and reality. The jets anticipated a slow reaction. They banked and angled for an intercept, relying on speed to close gaps quickly. Yet the Mustang rotated and pitched precisely, surging upward as though guided by intuition. The pilot timed his throttle adjustments, supercharger settings, and pitch with exacting care. Ice glittered on his instruments, frost obscuring edges of the panel, but his focus was absolute. In that moment, machine and human acted as one. The first pass was a test. The Me-262 approached at an oblique angle, expecting to roll and dive past the Mustang before it could react. Instead, the Mustang climbed faster, gaining altitude in seconds, disrupting the jet's line of attack. The German pilot flinched, adjusting trajectory mid-turn. Seconds were lost, and hesitation became the margin that would determine survival. The Mustang pilot didn't fire yet, he simply positioned himself with precision. Another jet emerged from clouds, He-162 this time, tiny but fast, attempting a vertical climb to intercept. The Mustang angled sharply, exploiting the reduced drag and aerodynamic advantage. The jet strained to maintain speed, engines whining under stress. In moments, the pilot had forced both jets to climb inefficiently, creating positional gaps. Each maneuver was calculated yet instinctive, a combination of physics, courage, and experience. Below, the landscape rushed by, forests blurring into gray-green bands. Frost fogged goggles, wind tore at gloves, and the roar of the Merlin engine dominated all sound. Yet he perceived everything: the angle of attack, enemy movement, subtle shifts in airflow. Every second of hesitation from the jets widened his opportunity. The canopy-less Mustang moved as if it had a mind of its own, responsive and precise, translating small aerodynamic advantages into decisive positioning. The first burst of gunfire was necessary. He leveled the Mustang briefly, aligning the sights with a Me-262 climbing to engage. Tracer rounds cut through thin cloud cover, striking fuselage and wing with precision. The jet wavered, engines screaming in protest. Another burst forced the second Me-262 to adjust course, preventing coordination. The Mustang pilot had already returned to a climbing angle, using momentum and lift to stay above, untouchable in the vertical contest. German formation cohesion began to break. One jet lagged behind, overextended in climb. Another struggled with engine throttle, unable to match acceleration during altitude change. The Mustang continued upward, exploiting both mechanical advantage and psychological disruption. Pilots who expected predictable engagement found themselves reacting to a machine they could not calculate. Every second of hesitation widened the gap between expectation and outcome. For the Allied squadron observing, disbelief gave way to admiration. The Mustang's performance exceeded all known limitations. The Canopy-less approach, initially dismissed as reckless, had transformed into a tactical advantage. The pilot had taken a calculated risk, leveraging aerodynamics, engine capability, and instinct to dictate the terms of engagement. Enemy jets, formidable on paper, were forced into defensive reactions. As clouds swirled and sunlight glinted off aluminum, the Mustang crested another ridge of thin air. The pilot maintained calm, knowing that the advantage persisted only as long as control and precision were absolute. Below, German jets adjusted, but the margin had been established. For the first time in that sector, a piston-engine fighter had demonstrated the ability to outclimb and outmaneuver jets in specific, high-altitude conditions. In those moments, seconds stretched into lifetimes. Each adjustment, each climb, each subtle tilt of the aircraft dictated survival. The canopy-less Mustang had become both shield and weapon, transforming risk into control. The first engagement concluded not in destruction but in dominance of positioning, proving that audacity, skill, and mechanical nuance could overturn expectations in the final months of aerial combat. January 14, 1945. Northern Germany, over a frozen river valley. The German jets regrouped, engines screaming, trying to anticipate the Mustang's next move. The pilot had gained a slight altitude advantage, but he knew the engagement was far from over. Every maneuver mattered. One miscalculation in throttle, pitch, or angle could be fatal. Ice formed along the edges of the canopy frame, freezing over instruments and control surfaces, yet he remained focused, reading both machine and enemy with acute precision. A Me-262 attempted a high-speed intercept from the sun, banking aggressively. The Mustang rolled and climbed simultaneously, exploiting the reduced drag from the missing canopy. The jet's engines strained under the climb, losing energy and forcing a corrective maneuver. The pilot held steady, angling upward, keeping both jets in his sights. Speed alone could no longer dictate the engagement. Positioning was now everything. Tracers cut through the thin cloud cover. The Mustang pilot fired in short, controlled bursts, targeting engines and fuselage. One Me-262 shuddered as rounds struck the fuselage, forcing it into a defensive roll. Another He-162 was caught off guard, climbing inefficiently while the Mustang gained altitude rapidly. In a matter of seconds, the pilot had created separation and forced hesitation, leveraging aerodynamic advantage over raw speed. The Germans attempted to coordinate a pincer maneuver. One jet dove from behind, banking for a high-speed pass. The Mustang rolled with precise timing, wind roaring past, climbing steeply as if pulled upward by instinct. The pursuing jet overshot slightly, engines throttled to compensate, while the Mustang gained energy and altitude simultaneously. Observers noted that the aircraft responded with unnatural agility for a piston-engine fighter, and they were not mistaken. The pilot pressed the Merlin engine, carefully managing supercharger settings to avoid detonation. Every foot gained in altitude widened the engagement envelope, giving him multiple attack options. Enemy jets, used to exploiting predictable Allied climb rates, now hesitated. Human instinct faltered in the face of unexpected performance. Hesitation, even for a second, created openings that could determine survival. Another burst of fire sent tracers arcing across the clouds. One Me-262 banked sharply, wings shuddering under stress, while the He-162 faltered in its climb. The Mustang pilot was above, poised, ready to capitalize on every misstep. The combination of reduced drag, high-altitude energy, and precise control made interception difficult, even for aircraft theoretically superior in speed. Below, the landscape rushed past in a blur of frozen rivers and forests. Frost clung to edges of instruments and goggles, but the pilot's focus never wavered. He anticipated movements, adjusted for wind shear, and exploited the jet's weaker climb capabilities. Each maneuver was deliberate, each decision the product of instinct sharpened by experience and audacity. The Canopy, once considered a necessity, had become a liability for the enemy in reading his performance. For the Germans, the psychological impact was profound. Pilots accustomed to dominating Allied fighters found themselves reacting instead of dictating. Their jets, powerful and fast, could not immediately respond to a piston-engine fighter gaining altitude with ease. Confidence faltered, coordination suffered, and the momentum of the engagement shifted. The Canopy-less Mustang had redefined the tactical possibilities in this sector. The decisive moment came as one Me-262 overextended its climb, losing energy while attempting to force the Mustang into a defensive position. The pilot rolled and positioned his aircraft for a controlled dive, placing the jet directly in the line of fire. A short, precise burst struck the fuselage, forcing the enemy to veer off. Another He-162, unable to match vertical acceleration, was forced into evasive maneuvers. Within moments, both jets were disengaged, retreating toward lower altitudes and safety. The Mustang pilot leveled, breathing heavily, frost streaming across his exposed face. The air was still, the clouds parting slightly as if acknowledging the end of the confrontation. The aircraft had climbed faster than any German jet in the engagement, defying expectation and demonstrating the combined power of mechanical nuance and human skill. Allies watching from nearby formations realized they had witnessed something extraordinary, an innovation born from daring, instinct, and intimate knowledge of the machine. As the Mustang banked and descended toward friendly lines, the psychological and tactical effects lingered. German pilots recalculated engagement strategies, Allies whispered of audacity and innovation, and the pilot himself reflected quietly on the delicate balance between risk and advantage. The Canopy-less approach, initially scorned, had become a symbol of calculated ingenuity. One minor deviation from standard practice had overturned assumptions, reshaped combat dynamics, and secured a rare victory in the skies over Germany. In the end, the pilot had not simply survived. He had demonstrated that human judgment, environmental awareness, and subtle mechanical adjustments could outperform raw speed and power. The engagement concluded, but its lessons would echo through briefing rooms, maintenance hangars, and the memory of every pilot who witnessed a Mustang outclimb every jet it encountered that day. January 15, 1945. Northern Germany. Reports arrived at Allied command the morning after the engagement. Pilots recounted in vivid detail the performance of the Canopy-less Mustang. Observers described how the aircraft had climbed faster than any German jet present, dictating the terms of the encounter. The pilot's audacity and skill had turned a seemingly reckless maneuver into a decisive tactical advantage. Commanders took note, astonished by the combination of ingenuity, mechanical understanding, and daring. Within the squadron, the mood was electrified. Pilots who had once considered flying without a canopy absurd now whispered about the potential. The psychological boost was significant. Witnessing one man exploit subtle mechanical adjustments to outmaneuver jets challenged preconceived notions of aircraft limitations. Confidence increased, and an appreciation for improvisation and adaptability began to spread. For the German forces, the reports were troubling. Intelligence officers noted anomalous climb rates in Mustang encounters. Me-262 and He-162 pilots, previously confident in their ability to dictate vertical engagements, were now hesitant. Logs reflected frustration, surprise, and careful recalculation of engagement tactics. The Canopy-less Mustang, previously considered a conventional piston-engine fighter, had become an unpredictable adversary. Even superior speed could no longer guarantee dominance. Field reports emphasized human skill alongside mechanical nuance. Allied mechanics noted that the canopy removal, though minor, had reduced drag, but the pilot's mastery of the aircraft had been essential. The combination of reduced resistance, optimized engine management, and precise maneuvering allowed for performance that defied conventional expectations. Engineers marveled, while tactical officers saw immediate implications for planning future missions. The effect extended beyond a single engagement. Mustang pilots began to experiment within safe limits, testing the boundaries of weight, drag, and climb potential. Informal lessons emerged in briefing rooms. Altitude advantage could outweigh raw speed. Precise throttle control and awareness of aerodynamic subtleties could determine outcomes, and unconventional tactics could surprise even technologically superior enemies. These insights were quietly shared, contributing to a culture of innovation at the squadron level. Enemy reactions were immediate in both tactical and psychological terms. German pilots reported hesitation, miscalculations, and unexpected exposure to Mustang climbs. Missions that relied on aggressive vertical interception now required adjustment, often delaying attacks or forcing alternative routes. This disruption of coordination amplified the impact of the Mustang pilots' innovation beyond the initial encounter, influencing broader air operations in the region. The squadron debrief emphasized adaptability. Commanders recognized that while raw speed, firepower, and design were important, human decision-making and precise mechanical understanding could be equally decisive. The Mustang pilot had demonstrated that a minor mechanical adjustment, combined with audacity and skill, could redefine engagement parameters. It was a lesson that resonated beyond the immediate skirmish, shaping strategy, training, and expectations for the final months of the war. In practical terms, the engagement confirmed that a piston-engine fighter could challenge jets under specific conditions. The canopy-less Mustang had leveraged physics, mechanical nuance, and pilot skill to achieve a vertical advantage. German jets, while faster in level flight, were constrained when forced into climbing engagements, especially when faced with an unpredictable opponent. This single encounter highlighted the intersection of human daring and mechanical adaptation, demonstrating that even small innovations could yield outsized results. By evening, the airfield buzzed with discussion. Pilots who had observed or participated in the engagement analyzed maneuvers, calculated climb rates, and considered the lessons for future operations. The canopy-less Mustang was not merely a curiosity, it was proof that improvisation, courage, and deep understanding of aircraft mechanics could tilt the scales in aerial combat. Tactical manuals would not capture it, and formal engineering analyses would fail to explain it fully. Yet the impact was undeniable. In the end, the immediate aftermath was a mixture of astonishment, adaptation, and renewed confidence. Allied pilots had witnessed innovation born from risk and insight, while German forces were forced to recalibrate expectations. The canopy-less Mustang, guided by an expert pilot, had rewritten the rules of engagement in that sector, demonstrating that daring, skill, and subtle mechanical changes could achieve results that technology alone could not. January 16, 1945. Allied airfields, Northern Germany sector. The story of the canopy-less Mustang spread quickly, though informally, through Allied squadrons. Pilots recounted the engagement with excitement and awe, emphasizing how one aircraft had defied conventional limits. It was no longer a single sortie but a demonstration of human ingenuity and adaptability in extreme conditions. The psychological impact on Allied pilots was profound. Confidence increased, not only in their aircraft but in their own ability to improvise and exploit subtle advantages. German forces continued to analyze the engagement with frustration. Reports described encounters in which piston-engine fighters outclimbed jets, forcing tactical adjustments. Commanders debated possible explanations: environmental factors, pilot skill, or mechanical anomalies. Intelligence officers began factoring in unexpected variables when planning missions, recognizing that assumptions about Allied aircraft performance could no longer be relied upon. Morale among Luftwaffe pilots suffered. Those who had expected dominance in the skies now faced uncertainty, hesitation, and the realization that even superior technology could be countered by human skill. The engagement prompted informal experimentation within Allied units. Pilots discussed canopy adjustments, throttle management, and climb optimization during briefings. Mechanics experimented with minor weight reductions and aerodynamic tweaks. While official doctrine remained unchanged, the lessons learned informed training and tactical awareness. Pilots began to recognize that precision, timing, and environmental mastery could yield advantages previously thought impossible. Risk, when calculated and controlled, became a tool rather than a liability. The strategic implications, though subtle, were significant. Allied planners noted that German jets, while fast and formidable, were vulnerable when forced into climbing engagements. This insight informed escort and interception tactics. Mustangs could now challenge jets in vertical confrontations, forcing them into inefficient maneuvers. The canopy-less approach, once deemed reckless, had opened a window of tactical opportunity. It became a model for leveraging human skill and mechanical nuance against superior technology. Across the squadron, pilots internalized the lesson: innovation often emerges in the margins, where boldness meets understanding of both machine and environment. The canopy-less Mustang became emblematic of this philosophy. In letters, logs, and oral histories, pilots recounted how one man had defied convention, transforming a small mechanical adjustment into a decisive advantage. It was proof that even in the final months of the war, creativity and daring could influence outcomes in significant ways. Enemy reactions highlighted the psychological dimension of air combat. Jets that previously dictated encounters now hesitated, misjudged altitude, or overextended in pursuit. Commanders noted that morale and confidence had shifted. Small deviations in aircraft performance, when exploited by skilled pilots, could create outsized effects on coordination, strategy, and engagement outcomes. The canopy-less Mustang demonstrated that human insight could amplify mechanical potential, and uncertainty became a weapon as potent as guns or speed. The engagement left an enduring legacy in pilot culture. Though official manuals never endorsed canopy removal, informal discussion and experimentation persisted. Pilots studied aerodynamics, practiced precision climbing, and learned to read subtle cues from their machines. The story of one audacious pilot transformed into a symbol of ingenuity, courage, and the unexpected advantages that arise when knowledge, skill, and daring intersect. By February 1945, the principle was embedded in collective memory. Allied pilots recalled the engagement during briefings, emphasizing the importance of observation, anticipation, and willingness to challenge convention. German pilots remained wary in encounters with Mustangs, often factoring in the possibility of unconventional maneuvers. In a theater defined by speed, power, and technology, the canopy-less Mustang reminded both sides that human skill could reshape tactical realities. Ultimately, the aftermath of that winter engagement was both immediate and lasting. Tactical doctrine adapted informally, psychological advantage shifted, and the Mustang pilot's innovation became a case study in improvisation. Mechanical adjustment, human skill, environmental awareness, and audacity converged to create an outcome that altered the dynamics of aerial combat in that sector. One aircraft, one pilot, and one calculated deviation from convention had left an indelible mark on both Allied and German perceptions of the skies. The canopy-less Mustang, frozen in memory and reports, would be remembered not for destruction, but for ingenuity. Its climb, outpacing jets designed for speed, symbolized the intersection of human daring and mechanical mastery. In the final months of World War II, where technology seemed to dominate, one pilot demonstrated that understanding, adaptation, and courage could tip the scales, leaving a lesson in history that would endure far beyond the Ardennes skies. The Canopy-less Mustang now rests in history as a testament to the intersection of human skill and mechanical understanding. One pilot's daring, combined with a subtle adjustment to an already exceptional aircraft, reshaped expectations in a theater dominated by speed and technology. The act itself was small, removing a canopy, but the implications were profound, demonstrating that ingenuity and audacity could redefine limitations. In the frozen skies of northern Germany, where frost and wind tore at every exposed surface, the pilot transformed risk into advantage. He trusted both his instincts and his machine, understanding intimately how physics, aerodynamics, and engine performance could combine to create opportunity. This was not recklessness but calculated courage, a recognition that knowledge, observation, and timing could outweigh raw speed. The human element, often overlooked in analyses of aircraft performance, had proven decisive. The engagement also underscores the unpredictable nature of innovation in wartime. Manuals, specifications, and conventional doctrine could not account for improvisation guided by experience. The canopy-less Mustang became more than a fighter. It became a symbol of adaptive thinking, of challenging assumptions, and of finding advantage in places others dismissed as too dangerous or trivial. Technology alone did not win the day. Human insight amplified it, creating outcomes that machines could not achieve unaided. For historians, engineers, and pilots alike, the lesson endures. The boundaries of possibility are often defined not only by design but by those willing to explore its margins. The pilot's ascent through the clouds, outclimbing jets built for raw speed, stands as a reminder that courage, precision, and understanding can transform the ordinary into the extraordinary. As winter skies cleared and the echoes of engines faded, one Mustang had proven that mastery of machine and self could tip the balance of battle. It was a quiet revolution in the air, a moment where human ingenuity met mechanical potential, where risk and skill converged, and where history was written not in bullets alone, but in audacity and insight. The canopy-less Mustang would live on in memory, reports, and legend, not because it destroyed more aircraft than its peers, but because it revealed the subtle power of human innovation. In the final months of World War II, one pilot's calculated defiance of convention left a legacy that endures as a lesson in courage, creativity, and the unexpected ways skill can triumph over assumed limitations.